Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 6 on our 2018 Euclid paper. So, as usual, for the middle of the Euclid, we've got a light bulb and a written question. So, 6a. For how many integers k, with k between 0 and 18 not inclusive, is 5 sine 10k degrees minus 2 divided by sine squared 10k degrees greater than or equal to 2. Okay, so first off, they're making this seem kind of scary looking. But I would notice that these k values, it's going to be 1 through 18, so what we're plugging into our sines are just going to be multiples of 10 degrees. So the numbers don't seem that scary, and I suppose we could, because it's a limited number, I mean, there's only 17 possibilities for k, because they are integers. We could, I guess, just grab our calculator and plug them all in, but let's try and be a little smarter about this. While that is a solution, it might not be the fastest way, and we don't want to waste time. Okay, we're getting to the questions that require a bit more thought, a bit more work, and a bit more time for the write-up. So we want to save as much time as possible, especially on the light bulb questions where no one cares how we got the answer, just as long as we got it. Okay. So the first thing I would do is say, well, the sines and the tens and that's just meant to look scary. So I'm probably going to simplify this by saying something like let x be sine 10k degrees. Okay? Because then what have I got? Well, I need 5x minus 2 over, I think it's just x squared. Alright, let's just double check that. Yeah, sine squared down there. So 5x minus 2 all over x squared greater than or equal to 2. Great, this doesn't seem so bad anymore. In fact, I think we're going to be drawing a parabola in a moment. But we can multiply by x squared, and that will not change things. You have to be a little careful. I tell this to my calculus students all the time. You have to be careful with inequalities when you multiply or divide, because if you multiply or divide by a negative number, the sign can change. But we're going to multiply by x squared, and x squared is always positive. Unless it's 0, but that actually can't happen with these range of values for k. So we just multiply by x squared, and the inequality will stay the way it is. So we'll get 5x minus 2 greater than or equal to 2x squared. I feel like we had this parabola in an earlier question. Anyway, we can bring everything over to the one side. Doesn't matter which side. I'm going to try and keep it so the coefficient in front of the x squared is positive. That's just my preference. So 0 is greater than or equal to 2x squared minus 5x plus 2. I think I'm thinking of question... Yeah, question 3 had the a... oh, it's plus 5x and minus 2, but I remember the a was definitely 2 there. Okay, well, good for me for remembering numbers, but largely irrelevant to the question. I feel like this can be factored, actually. 2x and then a regular x, so the 2x, say minus 1 and minus 2, those will multiply to positive 2. The 2x and the x will multiply to positive 2x squared, and then we'll have 2x minus 2, so that'll be minus 4x, and then minus another x. Yeah, that'll all work out. Okay, so what have we got? Well, we've got a parabola here, an upward-facing parabola, because I kept the coefficient here positive, and so it's sitting there, and we've got our x-axis. And at some point, we'll start to dip below 0, and that's what we're interested in. Now, where exactly we're going to dip below 0? Well, thanks to our picture, because we know it's an upward-facing parabola, we're going to be less than or equal to 0 specifically between the two roots. So rather than guessing and checking, I can just say, well, what are the roots? And the roots are going to be 1/2 and 2. Okay? And so then that tells me for x in the range from 1/2 to 2, we satisfy the inequality. Now, if you don't want to draw a picture and you're worried that you might not have the right range, take a random value like 1 in that range and check. 5x 5 times 1 minus 2 is 3, divided by 1 squared is 3, and that is greater than or equal to 2. So, yeah, that works out. Okay, so now the question is, well, what values of sine will be in this range? And we can have the 1/2 included. And you can check that as well. 5 times a half is 5 halves, minus 2 is going to be 1/2, divided by 1/2 squared is a half divided by a quarter. And that's going to be 4 over 2, and that is greater than or equal, it's the equal there, to 2. So that works out. So we need sine 10k degrees. Now, sine will never be more than 1. It can be equal to 1, so the 2 doesn't really sort of throw us off. And the way I would think about this is imagine a unit circle. Depending on how you learned trig, you might remember that, for a point on the circle that makes a counterclockwise measured angle from the positive x-axis, the height here is sine. Or sine theta, I guess. So we want to be above the y equals 1/2 line. So when is sine going to be equal to a half? Well, you might remember that happens when when you're sining 30 degrees. Okay, so you start with 30 degrees and then you go all the way around the circle. Any other value will work until you go back over here and dip below the line y equals a half. So for 30 degrees to, it would be 30 degrees back from 180, so 150 degrees. We've got sine is bigger than or equal to 1/2. So what does this mean for my k values? K specifically between 3 and 15, this time inclusive. So the number of k values is going to be, and then we just have to figure out, well, how many numbers between 15 and 3. And because it's inclusive, you do 15 minus 3 and then plus 1. Otherwise, you're missing out on a value. And that's going to be 12 plus 1, 13 such k values. K is 3, 4, 5, all the way up to 15. And if you want to, because remember, calculators are allowed, you can grab your calculator and you could check all of these, or you could say, did I really get those values correct? What if sine 20 degrees? Well, you can see it's going to be less than a half, and you can just do little double checks like that, but if you're confident in the math, you don't have to do that, and you can move right along to 6b, which is what I'm going to do now. Okay, so 6b. In the diagram, a straight flat road joins A to B. Alright, simple enough. Karuna runs from A to B, turns around instantly, and then runs back to A. Karuna runs at 6 meters per second. Starting at the same time as Karuna, Jorge, which I think I'm not pronouncing with the right Spanish accent, a Spanish friend of mine used to tease me about that, runs from B to A, turns around instantly, and runs back to B. Jorge runs from B to A at 5 meters per second, and from A to B at 7.5 meters per second. Now, Karuna, they just said runs at 6 meters per second, so I'm going to assume that that's constant for both trips. But Jorge, I think he needs some warm-up time, and then he gets faster on his return trip. Okay. The distance from A to B is 297 meters. I feel like they could have said that above, but that's fine. And each runner takes exactly 99 seconds to run their route. Determine the two values of t for which Karuna and Jorge are in the same place on the road after running for t seconds. Okay. Interesting. So I'm going to draw sort of a timeline picture-y version of this. There's A and B. And Karuna starts running this way, and Jorge starts running this way. Eventually, they're going to pass each other. Maybe at some point here. Jorge runs a little slower, so I feel like it's going to happen closer to B than it is to A. So that's a time T that we want. And then they continue on. Karuna will actually reach B before Jorge hits A. So at a later time, Karuna's here, and Jorge's not quite at A. Eventually, Jorge hits A. Karuna's already sort of instantly turned around and is starting to run back. Jorge turns around, and then eventually they're going to meet at the same point again. I don't know if it's that close to A or what, but those are the 2 times T that I'm trying to work out. Now, the first one is not that bad. Okay? So they have a distance of 297 meters between each other, and they are approaching each other. They are closing this distance. The distance between them is shrinking at a rate. What rate is it shrinking at? Well, Jorge's running and sort of canceling out road or chewing up road, or imagine, that he's got cleats on and he's just absolutely destroying the road, and the road is shrinking ahead of him because he's destroying it, and Karuna's also destroying it. So the road is shrinking, and how fast is it shrinking? Well, how quickly are they running across the road? Well, Karuna's going at 6 meters per second, Jorge is at 5. So combined, they are sort of eliminating or cleating up the road and sort of shrinking the available road space between them at a total rate of 11 meters per second. So, okay, 297, and now I see why they chose 297, because that's a multiple of 11. That's 27 times 11, so after 27 seconds, there will be no more road, and they will have met. So, and now this is a written question, so we should explain it. So I think I'll probably keep coming back to this picture, but the road between Jorge and Karuna on the, let's say, first leg of their journey is shrinking at a rate of 11 meters per second. And you could remind them it's 5 meters per second plus 6 meters per second, but they're going to see where you got the 11 from pretty quickly. So it takes 297 meters divided by 11 meters per second, 27 seconds to meet. And so that's our first time. They meet is after 27 seconds. Okay. So that handles our first meeting, and we need to, so at what time, so 27 is where they first meet. Let's write a little bit more. So 0 there, 27 they first meet. Now I want to figure out, well, when does Karuna hit B? Okay. So 27's good. Karuna reaches B after 297 divided by 6, which sadly it's not an even division there, but we can divide by 3 and say 99 divide. Wait, hold on. Didn't they say something like each runner takes exactly 99 seconds to run their route? So actually, I can work backwards, can't I? I thought I didn't take everything into account there. What I was going to do is say, okay, she hits this point here, and then sometime later Y, she's run back a certain amount of distance, and they still have to meet. But if I go one step after this point, it's they both hit the end at 99 seconds. Okay? So, yeah, because it takes Karuna 99 over 2, which is what I was about to write, seconds to go from A to B, and it's still a constant rate to go back, so 99 seconds overall. I just very quickly am going to double check that Jorge takes the same amount of time. So 297 over 5 is 59.4. That's how many seconds it takes Jorge to reach A. And then on the way back, he's a bit faster. 39.6, and if I add on, what did I even say? It was 59.4, right? So 297 divided by 5 plus 297 divided by 7.5, and yeah, it is 99. Okay, so I am reading the question right. Wanted to make sure. So I think we can just sort of work backwards, because what's happening at the end, sort of the reverse, is imagine they've met and then they're sort of running away from each other, and they're increasing the amount of road between them at a particular rate. Now, it's not 11 meters per second because Jorge is not going at 5 meters per second. But here we go. So, I might even say working backwards, because they do just want the 2 times, right? They do tell, yeah, the 2 values. So we don't even have to show that there's only 2 times that'll happen. Very, very simple here. Okay, so working backwards, from the 99-second end, they meet a second time at T, and the distance, or the road between them, increases at a rate of 13.5, which is half of 27, so this is looking like it's going to be very nice numbers. Meters per second, this time point out 7.5 meters per second plus Karuna's 6 meters per second. So it takes 99 minus t seconds to have that distance be the full 297 meters. So 297 meters over 13.5 meters per second is equal to 99 minus t. So you can either grab out your calculator or say, well, this is 27 times 11. 27 over 13.5 is 2. So this is going to be 22 is 99 minus t, and then rearrange and say 99 minus 22, and that's going to be 77. Okay, so that's our sort of our other point in time that we need to worry about. And so the other one was what? 27. So there we go. So the 2 meeting times are 27 seconds and 77 seconds. And that's all there is to it. Now, there's no reason you couldn't go through it this way, but rereading the question, then telling us that it actually takes the same amount of time for both of them to reach the end, just sort of reverse engineering from the end point, I think it works a little faster and less of a write-up as well. And that's always nice. Saves me more time for our next question, and that'll be question number 7. I'll see you for that in the next video.